Welcome. In the previous video, I talked about software, system software, and what is the role of the system software in computer system. Now, in this video, I am going to talk about the language and basic of language design. Basically, the topic of this video is basic of language design. Okay, why this theory is required? Why we are focusing on language design course? In the previous video, I also mentioned one point that software is required for end user, because end user, if they want to communicate with the computer system, they require some kind of software. Now the software can be designed on various language. As I mentioned, there are machine level language, then we have assembly level language, we have some high level language, but mostly preferable languages are written in form of high level form. So what is high level form? Normally the high level form means the language should be written in natural language. Natural language. So we are not going to use some binaries, that neither we are going to use assemblies, but we are going to use the natural language to write the program, write the software, design the software. But again, if we have the natural language, if we are writing everything in natural language, then the basic problem is computer system do not understand high level language, means the natural language. So if something is written in high level language, then it should be converted into binary, or we may say converted into machine level language. Okay, so this high level language should be converted into this particular form. So when the high level language is converted into the binary form, then and only then the computer system can execute those instructions. Otherwise there is no use of writing anything in high level form. We must stick with the machine level form. But this conversion is not done in one single step. There are multiple steps required to convert it. Let's see what are the steps required for this one. So if we have the high level language, the first thing we do with the high level language is we perform some kind of analysis. What analysis we are doing here? What kind of instructions are there? Whether those instructions is a legitimate instruction or not? Whether it is a right syntax or not? Everything we are going to analyze. After analyzing, what we are going to do? We are generating or we are converting the language into the machine level form. That phase is called synthesis. So in the analysis part, we are going to analyze whether the language which is written, or the program or the software which is written in high level form is really convertible, means there is no syntax problem. So in the analysis part, we are going to find uh, is there any syntax problem. That is the point we are going to discuss in the analysis part. The second point we are analyzing is which one is instruction which one is data, etc. These things are done in the analysis phase. Now, when everything is perfect, means there is no syntactical problem, we have identified lot of things, then we synthesis the language, converting this language into the machine level form or some other form. So we say machine level form. So that conversion is done in the synthesis phase. Now the analysis phase is not a one single phase, it is consisting of multiple sub phases. We will discuss all those sub phases later on, but one important sub phase is scanning. So what we are doing, this scanning is basically sub phase of analysis part. The scanning is a sub phase of analysis part, right? So what we are going to do in the analysis, this scanning part or scanning sub phase, we are going to convert the whole program into the token. So the program is converted into tokens, or sometimes called leximes. Okay. So what we are going to do here, whatever program is written by a programmer, we are going to break that whole program into a small meaningful unit, which is called token. So what is token? Let's define it first, and then we are going to talk about each token. So token is nothing but is a smallest meaningful information derived from the program and used to identify various building blocks of the program. Various building blocks of a program. Okay, so that is how I am going to how I define token. A token is nothing but a smallest meaningful information derived from the program, and basically it is used to identify various building blocks of the program. Now, what are the various blocks of the building blocks of the program? What we are going to identify here? So we are going to identify these informations, these points. So first point is what are the data types available in the program? What are the data types available in the program? Second, which or what are the variables? What are the variables? Third point we are going to identify is what are the literal. What are the literals? Fourth point we are going to identify is keywords. What are the keywords used in the program? So these things we are going to identify, and that information, if we encode that this thing, this particular thing is a identifier, this particular thing is a keyword, this particular thing is a literal, then that information is encoded in a token. Let's take an example of a token. Let us see, there is a very simple C program, that is int max equal to 10. Now here this is a very simple statement, possibly from the C program. So what we are going to identify from this particular line? The int is a data type. Max is a variable. This is a data type. This is also a keyword, right? And 10, it is literal, right? So int max, then that we are going to identify. This int is a data type, this is a keyword, this is max, which is a variable, 10 is a literal. So that we are going to identify by having a token. So token we will discuss later, but first question is how we are going to identify that this is a identifier, this is a keyword, this is a literal. How we are going to identify it? So basically, to identify any sort of building block, we require regular expression is used. Okay. So if we want to identify which one is identifier, we are going to use the regular expression. The same thing we are the regular expression is used for identifying literals, identifying keywords, etc. So we need to talk about regular expression. What is a regular expression, right? Once we get knowledge about regular expression, then we can write programs, we can write or we are able to identify all those informations from the program. So in this particular video, the main focus is regular expression, but to start the regular expression, from my point of view, the regular expression is not the starting point of the discussion. I need to start with some basics and then I go to the regular expression. So here we will establish some concrete mathematical concept which is required for understanding the regular expression. So before going to the regular expression, I would like to talk about finite state machine. This is the topic for this particular video. Now, the finite state machine, the machine doesn't mean it is really a hardware part or the machine part, but machines are defined like an uh, mechanism for solving some problem, right? So whatever mechanism we devise, possibly it may be the hardware part or it may be the software part, everything is called a machine. Now, finite state machine is a kind of machine which solve problem by using some finite information, right? So we will discuss about all the states. But before discussing this point, some mathematical point I need to discuss. One point I want to discuss or I want to define is symbol. Now the symbol is basically the atomic information which cannot be subdivided, which cannot be divided further. So it is an entity, it is an atomic information, atomic kind of yes, it is atomic representation. How you can define the symbol is just a piece which is not further divided. So we say it's atomic information. Okay, so it's basically the atomic information. Like we can say A, it is a symbol, we cannot divide it further. B, it is a symbol. Alpha, it is a symbol. 0 is a symbol. 1 is a symbol. A is a symbol, and so on. So these are like symbols. Now, second point which we want to discuss is a string. Basically, there is no perfect definition for the symbol. It's simply like an atomic thing which represents one information possibly. So, what is a string? A string is a set of symbols juxtaposed. Set of symbol juxtaposed. The meaning of this statement is it is a set of symbols concatenated to each other. So other thing is set of symbols which is juxtaposed or concatenated with each other. So it's nothing but if you collect some symbol and concatenate it, then you get some of the string. So let's say I have three symbols A, B, and C, and then I what you can say, I made a string, say AB. This might be one string out of these three symbols. Another string possible is AC. Another string possible is ABC. Another string possible is BC. One more is possible like BCA, etc. So all these things are nothing but a string. So if we take one symbol, then another symbol is concatenated with that symbol, and whatever be the resulting is a string, right? So this is what we define. Third definition which I require here is called third is alphabet. So what is alphabet? Alphabet is nothing but set of symbols. Okay. So if we have some symbol and we take it in one set, then it is called alphabet. Normally the alphabet is denoted by this sigma. So denoted by sigma, right? Fine. So let us say we have the alphabet sigma equal to A, B and C. We have taken three symbols A, B and C, make a set, and that set we say it's an alphabet. Okay. So this three information is required to discuss the finite state machine. And another information which I require is some operation on the alphabet. Let us say we define sigma n, that is equal to combining symbols from sigma n times. Okay, or basically not combining, we can say concatenating. Concatenating symbols from sigma n times. So let us say sigma is equal to A, B, and then I want to define sigma 2 or sigma squared. It means I need to concatenate symbols from this set two times. So one possibility is I choose A and concatenate A two times, so I get AA. Then I choose B and concatenate it with B. Okay, so that is another possibility. If I choose A, then the second symbol I choose is B, and third possibility is, fourth possibility is, first I choose B and then I choose A. So that is the meaning of sigma square. Now if I think sigma cube, it means I need to take some of the symbols from this and concatenate it 3 times. So if I choose to have A, then I have A, that may be one possibility. Another possibility is A, okay. Third possibility is A. Then we have A, that is another possibility. Then we have B, A. Then we have B, A, and then we have B. 1, 2, 3, 4, 5, 6, 7. There may be one more. Possibly there may be one more. That is A. Right? One is missing. That is A. Okay. So this is what the meaning of this sigma raised to n. Now there is one more notation which is used in finite state machine. Discussion of finite state machine is sigma star. So what is sigma star? The sigma star is equal to sigma 0 union sigma 1 union sigma 2 union, it will go for the infinity. Now sigma 0 means symbols concatenated 0 times. So in that case, sigma 0 is always equal to the empty string. This epsilon, it is sometimes called empty string, right? So sigma 0 means I am not going to take any symbol from the set, and that's why I am getting a empty string. So let's discuss what we will get if our sigma is this one. If sigma is equal to A, B, then sigma star is equal to, first we need to think about the 0 combination, and 0 combination is nothing but epsilon. So we are getting epsilon. Second is we need to think about single combination. So what is the single combination here? We either get A or we get B. That is the only possibility. Now then we need to think about 2 combination. So we take A 2 times, that is one possibility. We take AB, that is another possibility. Third is we get BA and we get BB. So this is the 2 combination. So this is 0 combination, this is 1 combination, this is 2 combination. Then we need to think about 3 combination, we need to think about 4 combination, and so on. And then if we make this entire set, then that set is called sigma star. Okay. Now one more definition I want to use here, or term which I want to use here, is language. Normally, language is denoted by L. Okay, so language is what? It is denoted by L. And what is language? Language is nothing but a subset of sigma star. So a language is nothing but what? The subset of sigma star. So whatever sigma is given, we can get sigma star, and then some of the symbols from the sigma star, if we choose, then we get a language. Let's think about this. If we have the sigma is equal to AB, then obviously sigma star is equal to epsilon A, B, AA, AB, BA, BB, and then this is a 2 combination. If you think about 3 combination, it is AAA, AAB, ABA, ABB, then we have BAA, BAB, BBA, and BBB, and so on. So what I can say is language L, then obviously L is some subset of this particular language, some subset of sigma star. So if we are choosing epsilon, we are choosing A, we are choosing ABB and BBB. Obviously this L is nothing but subset of sigma star, and L is a language. Another way the language is defined is, a language is nothing but set of symbols, not set of strings. So set of strings is called a language, and it is basically denoted by L. So let's take some example of language. Say L is a language over sigma equal to AB, such that uh, x belonging to L, then length of x is less than equal to 2. What is the meaning of this statement? L is a language over sigma, and sigma is already given, such that if there is some string in L, then the length of L, this stands for length. So length of that particular string is less than or equal to 2. So first of all, what is sigma star? The sigma star is nothing but epsilon A B A B B A B B, and then it will keep on going. Now we need to choose such a subset which satisfy this property. So what is that property? The length of the string is less than equal to 2. So we need to choose those strings from this set whose length is obviously less than equal to 2. Yes, if you think about the set properly, the set is not stopped at this point, it is going on. Let's say another is AAA, AAB, ABA, ABB, then we have BAA, BAB, BBA, BBB, and then keep on going. So what we need to choose from this set is all the strings whose length is less than 2. So what is the length of this? Epsilon means the empty string, the length is 0. If we think about this, then what is the length? Length is 1. What is basically length? The length is, if we define length of x, then the length of x is defined like number of symbols in x. That is how we define the length. So how many symbols we have in epsilon? There is no symbol, so the length is 0. Obviously 0 is less than equal to 2, so we need to include this into L. Then the length of A is 1 because there is one single character, so that should be included in this L because the length of A is obviously less than equal to 2. Now this B, the length is 1, we need to include it. What is the length? This is 2, we need to include it because the length must be less than but also equal to. AB, it is not AB, should be AA, there is A also. So we need to have AA, BA, BB. Now all these strings is having length 3 and 3. So 3 is obviously not less than equal to 2, so we need not to include these things. So this is what the language L, and it is containing these of the strings whose length is obviously less than equal to 0. So this is one language, and obviously it is a subset of sigma star, so it's very easy to get it, right? See, another what we can say example of the language is L is a language over sigma offset 0, 1 such that x belonging to sigma, then x is divisible by 2. X is divisible by 2. Here the sigma is 0, 1. 0, 1 means it kind of binary. So let's write sigma star first as usual. So sigma star is epsilon. Epsilon means empty string. There is nothing 0, nothing 1. It is 0. It is 1. It is 0, 0, 0, 1, 1, 0, 1, 1. Then we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Then we have 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, and so on. Now, if you look at this particular set, then these are nothing but the binary number. So, if we think what is this binary number in decimal, this is 0, this is 1, this is 0, this is again 1, but this is 2, this is 3 in decimal, this is 0 again, this is 1, this is again 2, this is again 3, this is 0, 1, 2, 4, this is 5, this is 4 and 6, and this is 7, and so on. So, what is the language? Language is saying all the string which is available in that language should be divisible by 2. Basically, divisible by 2. So, which of the strings are divisible by 2? Obviously, 0 is divisible by 2. 0, 0 is also divisible by 2. 0, 1 not divisible by 2. The 2 is itself divisible by 2. 3 is not divisible by 2. 0, 0, 0 is divisible by 2. 0, 0, 1 not divisible by 2. 0, 1, 0 is divisible by 2. This 3 is not divisible by 2. 1, 0, 0 is divisible by 2. Then 1, 1, 0 is divisible by 2, and so on. So this is the language in which every string is divisible by 2, right? So this is a language. Let's take one more example. So L is a language. L is a language over sigma is equal to A and B such that if X is belonging to L, then number of A in X is even. Okay, how you will read this statement? Number of A in X. So number of A in X should be even. So first of all, we need to write sigma star. What is sigma star? It is epsilon A, AB, starting with the B, A, AB, BA, BB, then AAA, AAB, ABA, ABB, BAA, BAB, BBA, BBB, keep on going. So this is what the sigma star is. Now what is L? The language. Here it is said that number of A in X should be even. So this one, as the length of this is 0, it is not containing any A, it is also not containing any B. So this epsilon is equal to no A, no B, right? And no means 0 number of A, 0 number of B. And what is 0? So 0 is even, right? 0 is even. So if there is no A, then also it is considered as even because it is 0. So we need to include this epsilon. Now here we have 1A. Okay, so the number of A equal to 1 in this particular string, and 1 is odd. So we need not to take this. Then we talk about B. Number of A is equal to 0 because there is no A in this B, right? And 0 means what? The even. So we need to include the B. Then here we have the AA. What is the meaning of AA? We have number of A equal to 2. So there is 2A, and that is why the 2 is even. So we need to include it. AA. AB, number of A is equal to 1 because there is 1A and 1B. So 1 is odd. So we need not to include it. This one again, the number of A equal to 1 because there is 1B and 1A. So it should be not included in this set. Now here it is BB. So number of A is equal to 0 because there is no A available in this set, in this string. So it should be added. BB. If we think about AAA, number of A is equal to 3. So it should not be included. If we think about AAA, number of A is equal to 2 because we have 2A and 1B. So we are thinking about only A, so we should include it. A, B. If we think about this, there are 2A, 1B. So number of A equal to 2 and 2 is even, so we are going to add it. A, B, A. Now if we think about this particular string, there is number of A equal to 1. So there is only 1A, 2B. So we are focusing on A, the number is 1. So we are not going to include it. In this case, number of A equal to 2 because we have 2A, 1B. So we need to include it. B, A. Right? If we think about this one, the number of A equal to 1 because there is only 1A and 2B. Here also the number of A equal to 1. Here the number of A is 0. 0 is even, so we are going to add it. So this is what the language is, right? So language is like a subset of sigma star, fine? And obviously it might be possible that it is following certain condition. Okay? Let's take one more example, a more complicated example of language. L is a language over sigma equal to A, B such that if X is belonging to L, then number of A in X should be equal to number of B in X, right? Number of A in X should be equal to number of B in X. So what is sigma star? It is very easy to write now. Sigma star is epsilon A B, AA, AB, PA, PB, AAA, AAB, ABA, ABB, BAA, BAB, BBA, BBB, and keep on going. Right? So what should be the L? L is saying number of A equal to number of B. So let's count down how many numbers of A we have and how many numbers of B we have. So here the number of A equal to 0, number of B that is equal to 0. So both is same, the number of A and number of B is same. We are going to include epsilon in this set. What is A? Number of A equal to 1, number of B equal to 0, because there is no B. So both are unequal, so we are not going to add it. In same case arises with B. So B is not included in the set. AA, the number of A equal to 2, number of B equal to 0. So both are unequal, so we are not going to add it. Here number of A equal to 1, number of B equal to 1. Both are equal now, so we are going to add it. AB. Same case, we have 1A, 1B in BA, so we should add it. BA. BB, number of B equal to 2, number of A equal to 0, both are unequal, not going to add. Here AAA, number of A equal to 3, number of B equal to 0, both are unequal, not going to add. AAB, number of A equal to 2, number of B equal to 1, unequal, not going to add. Here number of A equal to 2, number of B equal to 1, unequal, so we are not going to add. Here number of A equal to 1, number of B equal to 2, so it is 1 and 2 unequal, we are not going to add. Here hash number of B is equal to 1, number of A equal to 2, unequal, we are not going to add. If we count here, we have 2B, 1A unequal, here 2B, 1A not equal, here 3B, 0A not equal. So if we continuing example, we will add more. So this is what the language is, where the number of A and number of B are equal. Right? So these are some examples of language. Fine? Okay. So for this particular video, it is enough. We will discuss more about language and finite state machine in the next video. Thank you.